Welcome back. This is R for economics. Now we've dealt with logical operators. These are the ampersand, the vertical line to say and or. So those are the logical operators. But what about the mathematical operators? What do they come out with? So if we have 100 is greater than 95, what does that tell us? Well, that tells us, well, that's definitely true. And is 100 less than 95? No, that's false. What about equals? Now to do an equals, we do double equal sign. And that's false. Of course they're not. 95 does not equal 100. So what about a sequence? If we have a sequence from 90 to 100, and then we have greater than 95, what do we see? Well, false, 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 true, 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 true. So this went from 90, 91, 92, 93, 94, 95. 95 is not greater than 95. They're the exact same. 96, 97, 98, 99, 100. So what about the not function? Remember we had a not that we put in front. Well, if we have 90, same sequence, unexpected error. Oh no, this is terrible. What do we do? Well, if we do a not out in front, then it'll switch our signs. So we can't put the not directly in front of some functions. However, we might be able to do it for an equal sign. Why? Because an equal sign is a special kind of function. Let's give that a try. Let's try 90 to 100 not equal to 95. Well, that's true everywhere except for where it was 95. So we can, this is a special function itself where it says not equal to. This was equal to, this was not equal to. It saves you the time of putting in a not and parentheses around the entire logical function that you're putting in, logical mathematical function. What about greater than or equal to? Well, that's pretty simple. Now 95 is true, just like all the rest. So it's greater than or equal to. There is also less than or equal to. Where less than 90 or equal to 95, and so on. So we can also set our sequence, and we can actually test this through values of functions. So we put this in as variables, x and y, and we go through and go, oh, well, anything 95, anything greater than or equal to 95 will come back as true. So if we can also set this as an actual variable itself. So now we've got our function here. It says it's a logical function going through. And if we want to print it out, look, we've got z, and that's our variable. What happens if we multiply a logical function by 1? Wow, now we've just got a number. And if we print it out, we can see that it's zeros where it was false, and true becomes a 1. So it's a binary function back and forth. This will be useful later on. Now, what else can we do? Well, we can have these functions and say, well, maybe we can pass them into a function, if function, in order to do something. So if this is true, it should print. Well, let's see what happens. Oh no, what's happened is z is its length is greater than 1. Is that true? Length z, what? Length z is 11. Well, that's absolutely true. It's greater than 1. So what if we pass it just one element? Let's go with the second element, which would be false. And if we do that one, it prints out and does not print the statement. Well, what about 10? 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 is true. Hey, look, it wrote variable is true. Is there something else we could do? Well, we could actually just pass it an argument, an if statement, an argument directly, our logical statement. Does it know what to do with it? It does. It says this is true. Excellent. So we are able to use these logical math functions, operators, in order to get logical functions as output, trues and falses. And then we can convert those to zeros and ones if we need to. And we'll see you in the next video.